Anyway, good morning. We're slightly behind schedule, but we have the Professor Gupta's group, Capacity Planning at DWC, and thankfully I'm able to read the numbers. Now, we do have family in the audience today. Thank you very much for joining us.
Wait, gentlemen.
All right. Hello, everybody. My name is Peter Arena. Along with me, I have Nick Tillett, Colin Thomas, Keegan Lynch. The faculty sponsor, Dr. Gupta. The facility sponsor, Tim Cross. The director of supply chain at Bradford White. Together, we're bringing you Bradford White Capacity Planning. A little bit of background on Bradford White. They're a water heater manufacturing company based out of Middleville, Michigan. They produce both gas and electric powered water heaters for both residential and commercial use. They're founded in 1881 and now employ nearly 2,000 people. So upon our initial visit to Bradford White, several needs for the project arose. The first of which being a shortage of in-house head and base pan produced parts. These shortages caused supervisors to have to schedule several shifts of overtime throughout the week. Not only were they having to schedule overtime, they were having to revise and reassign the stamping department schedule. Tim also expressed the need for a tool to measure the presses within the stamping department. Our team has set 3 major goals for our project. First of which being the creation of the capacity plan for the 5 presses in the stamping department. We will also provide inventory organization improvements and generate an attainable schedule. To help ourselves reach these goals, we have devised a set of deliverables we provide throughout this project. The first of which being the capacity plan itself. Within the capacity plan, there will be an attainable schedule that can be used to meet set performance measures and forecasted demands of the company. We will also provide work in progress flow improvements, inventory organization recommendations. Next, Colin will talk to you guys more about what a capacity plan entails.
So as Peter mentioned, our first step was to create a capacity plan. Capacity plan is a tool that companies use to be able to assess their systems and processes if they're going to be able to meet future and growing demand. So a really good tool that the capacity plan entails is the ability to evaluate machinery within a process. So it would tell engineers and operations folks in a company when those machines are going to need to be repaired or replaced if they can't meet future demands. To build a capacity plan, it takes a lot of data collection, manufacturing standards, and when you're collecting those, a lot of times you're able to evaluate and come up with ways to increase production and make things run more smoothly within the system. So once you have all that data collected and put into your capacity plan, you're able to evaluate how well your system is going to be able to meet future demands and what changes need to happen before you can meet those. So when you have that, you're able to come up with some improvements, whether that be on the engineering side, supply chain side, or operations side, to be able to meet those future demands and make sure you're meeting your customers' expectations. Once you do that, you can implement your plan into the system and allow your capacity plan to track how well those changes are helping to meet future demands. So to begin building our capacity plan, we started with our data collection, which was the biggest part of our project. So we started by collecting time studies. Time study is a tool used by companies to evaluate how long it takes a machine or a person to finish a piece of work. So in our case, we were evaluating the 5 manually fed presses at Bradford White. In the accurate time, we broke this work up into elements. These elements included manually loading the pan into the die, cycling the press, and then unloading it. These had to happen every time a finished part was completed. And then also stacking and staging of finished and non-finished goods. Those happened less frequently, so they had less impact on the overall cycle time. So once these were broken to elements, we collected times with stopwatches and videotapes. These were plugged in to our time study table as shown right here. And this gave us a good look into how long it took to complete each element Since these are manually driven operations, this was very important. We also incorporated operator ratings and percentage allowances for the work environment and how hard the operation was to complete. So once all this was plugged into our tool, we were able to get cycle times and hourly rates for the over 100 parts that get run on 5 presses that we're looking at. More data that we need to collect. Started off with some critical machine information. This is a picture of the manually fed dies that we're looking at. We had to collect data on the size of the machine, what dies can be run in the machine, and how many strokes per year the machine sees. And when we refer to tooling, we're talking about die sets like these ones right here. For the tooling, we had to collect the size of the tool, where the tool can be used, and what parts come out of each die set we had to look at. We also had to look at how many people were available to run these presses. So Bradford White runs a 3-shift operation in their stamping department. On first shift, there's only 3 people available to run these 5 presses. This means that only 3 out of the 5 presses can run at one time. Nick will mention this later, but as most of you know, finding labor in this environment is fairly hard. Second shift and third shift only have 2 operators available to run these presses. So we had to dig into old schedules and old production reports to see how well they were able to meet the needs of their schedule and how fast they were able to run certain parts. For our capacity plan, we used the 2020 volumes seen by Bradford White, but we also forecasted into the future for growing demands to be able to evaluate if our systems could meet our growing demands. We also obtained quotes from outside manufacturers when we started to look into outside processing, or OSP. OSP is when one manufacturing company has another manufacturing company make parts for them, bring them back to them for final assembly. So we got quotes from other suppliers for that. We also looked into operations that it took to complete a head and base pan. These head and base pans may look simple, but some of them take up to 5 different stamps in a press to be able to use as a finished part. So that all played a role in how long it takes for a finished header base pan to be completed. We also looked into changeover times. We used our same time study tool to be able to look at these. A changeover is when one die set is taken out of a press and a new one is put in to be able to run different parts. Here's a picture of that. So with all this data, we really needed a way to organize it so that our team could use it. So we built a matrix Excel tool to be able to filter and organize this data as we needed it. It also allowed for greater visibility as we started looking at improvements that we could make as we started to build our capacity plan outline. This matrix is being used by engineers at Bradford White currently to work on other projects, as the manufacturing standards involved are very helpful. So as we start to put together our capacity plan outline, we spent a lot of time doing research on what other companies are doing, how it's being helpful to them, and how we can form it into our unique system that we're looking at Bradford White. So to begin that, we gave press and die assignments for each part to be able to organize it that way. And then we brought our capacity plan outline to Tim Cross and Bradford White for them to evaluate it. Tim suggested that we start to look at targeting an 80% utilization across all 5 presses. 80% seems low, but there's a few reasons that we do this. It's because of emergency changes at the assembly lines. If we need to change our schedule in the press room, it gives us extra capacity to be able to meet those demands. And then also the 11th hour customer, if we have a customer come to us late that needs parts now in the 21st century manufacturing, that's very important, and we need to meet those customer demands. Now I'll give it to Nick to talk more about our utilization rates.
So on this slide, you can see a section of our capacity plan. In the first two columns, we have the tool number as well as the part number. Next, we have the 2020 volumes as well as the weekly volumes, which we calculated the weekly volumes by dividing the 2020 volumes by the 48 run weeks in the year. We have a big changeover and also a small changeover. The big changeover is when you remove the die from the press and replace it with a new die, compared to a small changeover is when you keep the die in the press but change just a few features of that die. Next, we have the parts per hour, and finally the actual runtime, which we calculated using the weekly volume and also parts per hour. We use this data to start calculating our utilizations. The first equation we had to use was the available runtime. This is the number of operators multiplied by the available runtime per operator divided by the number of presses that were in use at the time. We then use this to solve for the utilization rate. This was the weekly volume divided by the cycle time, plus the changeover time and preventative maintenance. This is all then divided by the available runtime. We use these equations to find the current rate at which Bradford White was currently at. On this slide, you can see these are the current state of the press utilization. We use this by using the primary press given to us by Bradford White. We found an 115% average utilization, which normally could be lowered by adding labor, but in this instance, we are not allowed to do that because of the tough times with labor shortages. As you can see, press 858 has a 265% utilization. This number isn't possible to reach, so we reached out to Bradford White to see how this could be possible. We found that the supervisor spends an hour of his day every day spreading out the volumes across the 5 presses to make sure that they can run smoothly. So when we heard this, we decided to make scheduling changes to fix this. The first thing we wanted to do was rearrange the press assignment. So we had to go through all of the dies to make sure which dies could fit on what presses. And what we found was that most all dies could fit on any of the 5 presses. So this was an easy fix. The next step was working on labor allocation changes. What we did was focus on the overutilized presses and add more available runtime to drive down the utilization. The next fix was to work on reducing changeovers. The first thing we did was to group similar parts so we were allowed to keep the same die in the press without having to change it out. The next thing we did was set a rule of 100 part minimum runs. This would make sure we didn't have any small batch sizes to also decrease changeovers. And the final step was to make sure we ran all of the operations for one part in a row before moving on to the next part. And the last scheduling change we had was to look into outsourcing options. Using the schedule, we found the new recommended state. So in the yellow, you can see the recommended state with grouping similar tooling, reduced changeover times, and also changes to the labor allocation. This gives us a 95% average utilization, but still leaves us with overtime and also doesn't give us time for the 11th hour customer. Because of this, we looked into outsourcing recommended state. This in the green, this is the utilization we would have if we outsource 2 parts. And we'll talk a little bit more about that on the next slide. So here are the volume with all 5 presses, the volume of all 5 presses. And in the orange, you can see the volume of the 5 presses without the 2 dies. We decided to outsource die 412 and die 413 because they make very similar parts. They make the exact amount of volume we need to reduce to reach our mark that we would like to meet. With this happening, we would have a reduction in production by about 11.5% and gives us a 79% average utilization across the presses. We used a make-buy analysis to see if it's worth making these parts on overtime or if it's worthy of just outsourcing, and we found it is cheaper to outsource the products. And these are our final recommendations for the capacity plan and also the scheduling, and I'll have Keegan talk to you more about inventory.
The next area we looked at was inventory management. Everything pertaining to this is all recommendations we've made for Bradford White. And to best manage inventory, the big things you need is organization and accessibility. So to do this, we wanted to recommend having. Okay. So to do this, we wanted to have set areas of different sizes of inventory that we would mark with color codes with painted lines around the edge. And then we'd have signs hanging above to indicate what inventory is below. We'd also have new labels on the we'd also have new labels on the storage bins that would have barcodes that high-low drivers could scan to ensure that the inventory is taken to the right location. So the two factors we need to consider for this is that every high-low driver would need to have a barcode scanner, and that the areas for storage would have to have good accessibility for the high-low drivers, as well as enough room for maneuverability around them. So this is our proposed inventory structure. So you can see that everything is color coded with different size pans for each color, and sizes for each storage location is dependent on the maximum and minimum estimated storage amounts for each inventory type. Next, I'm going to break down the savings that we estimate we'll be able to save. So on the left, we have the make-buy analysis that we've created. It compares the cost for running parts in overtime versus outsourcing those same parts. And we estimated we can save Bradford White about $23,000 a year. On the right, we have the time savings. So we estimate we can save the supervisor with our plan an hour of time per shift, and we can save the company as a whole 20 hours of overtime per week. We estimate that we can reduce the press utilization by 35% and reduce the volume that they output by 12%. Overall, we added together and we estimate that we can save Bradford White yearly with our plan $82,000. We broke our conclusion and recommendations into two separate categories. The first pertains to the capacity plan and scheduling, and the second category pertains to the inventory. So first, we recommend grouping the part numbers based off of the tooling, creating parts, and assigning each die to a press. This will help streamline the manufacturing process. Next, we recommend having runtime parts running for at least 100 parts per run. And we estimate this will increase the run times and decrease the changeover times. Finally, we recommend that they outsource some parts, so then the utilization rates aren't as high as they have been. For inventory, we recommend creating labeled sections for each inventory type on the floor, as well as introducing new barcodes and labels to storage areas. Finally, we'd like to thank Tim Cross, Bradford White, and Dr. Torun Gupta for sponsoring us with our project. And we'd like to thank Zach Seddon and Dana Hammond for their assistance throughout the project. Thanks for listening to our capacity plan. We'd like to take any questions you have right now.
Any questions from the room?
Has your plan been implemented or in the process of implemented?
Yes, I actually sent the plan 2 days ago to our master scheduler, and he's starting to use it.
Very good.
I have a question.
Any idea about, you may not know the answer to this.
Yeah.
But that's all right. What is, on the average, what is the reduction in number of changeovers with your plan?
So with our set weekly schedule right now, I think it's going to go down from an average of 5 to 7 changeovers per shift to around 2 or 3.
On the average of all 5 visits?
Yep.
Thank you.
Anything else in the room? Yeah, that's something I wanted. So you said that your group has that capacity plan to Bradford White. Which
You
also-
missed all of the parts.
I think they may be attending, but we have not done the presentation directly to them.
So they,
But their project would save $82,000.
were, they just trusted it.
No, we had met with them probably 4 or 5 times throughout the project, and then we showed them our presentation and our final capacity plan for them to look over. So
Bradford White, are you online? Okay. Any questions online? All right, thank you, gentlemen, well done.